Now we're getting back into ellipses here, and we're going to consider the simplest of the ellipses as far as the information and finding certain key ideas about the ellipse, and that's the ellipses with the center at 0, 0. In the example that I derived, I ended up with this equation here, and I had a drawing somewhat like this as far as where the foci were and what the values are. The distance from the center, 0, 0 in this case, to either one of the foci is a distance of c. This point, the furthest point where it crosses the x-axis on this elongated horizontally ellipse, this point here and this point over here on this side, those are called the vertices. Okay, I put a V there for vertex, and that is a distance of a. Remember, if you recall, a is that number underneath the x squared. A is a positive number. The points where our ellipse, our curve, our oval shape, crosses the y-axis on this first diagram are at 0, b and 0 opposite of b. This distance b here being smaller than a. And we call these 2 points the co-vertices. Some books call them the co-vertices. This book calls it a little bit different in that they say that the distance between the vertices, this line segment, is called the major axis, and this line segment from the co-vertices is called the minor axis. And we say that the co-vertices are the endpoints of the minor axis, just as the vertices are the endpoints of the major axis. All right, so lots of information here. There's a relationship between A, B, and C. Remember, A is the, or 2A is the distance, the sum of the distance from any point on this curve to the 2 foci. So if I was to go here to point B, this distance here and this distance here, that would have to add up to 2A. That would mean, since I have symmetry here, that this is A, that this distance here is B, and that this distance here is C. If I use the Pythagorean theorem, I get A squared equals B squared plus C squared. That's an important relationship between the numbers A, B, and C here that you're going to need to know for ellipses, whether their centers at 0, 0 or not. So if we have the foci on the y-axis, still with center 0, 0, we get an elongated vertically oval shape, the ellipse there, and its vertices are up here at 0A and 0 opposite of A. Its co-vertices are at B0 and 0, or excuse me, opposite of B0. Okay, the vertical is now the major axis, the horizontal is now the minor axis, and the equation looks like this. So when it's written in this form, the bigger number underneath the variable tells you, just by looking at it, is this elongated horizontally or is it elongated vertically? If the bigger number is under the x squared, it's elongated, or any expression in the x there, it's elongated horizontally, where if the bigger number is under the y squared, it's elongated vertically. Now remember, the relationship is a squared equals b squared plus c squared. You can see that a is bigger than b. Alright, so this is always going to be bigger than this. So I have the centers at 0, 0, but for these types you can see the slightly different information. Here the vertices are at A0 and opposite of A0. Here at 0A and 0 opposite of A. Here are the foci for both, and here are the co-vertices for both. Now, the length of the major axis from here to here is 2A, which makes sense since this distance is A and this distance is A. The length of the minor axis is 2B. That'd be this amount because this is B and this is B. And remember, A and B are positive. A is considered what we call the length of the semi-major axis. I know, that's a lot of vocabulary. The semi-major axis, that's the distance from the center to either one of the vertices. B is the length of the semi-minor axis, which is the distance from the center to either one of the co-vertices. Okay? But in this case, you have to remember here, you're not going to see all this vocabulary thrown at you, and I rarely see semi-major and semi-minor axis listed, but I believe that this textbook does like to use that terminology, so kind of get used to that. And of course, the actual graphs that are in green, the oval shapes there being the ellipses. So now, I'm going to do a couple of examples here where I'm going to graph ellipses, but I'm also going to list some of this key information here. First example says graph the ellipse and then identify the vertices, the center, the vertices, the minor axis endpoints, that's the co-vertices, and the foci. These are all ordered pairs here. And as you can see, this fits this form right here because the bigger number is underneath the x squared. So it's going to have center 0, 0, and so on. A squared is 9. So a positive number, must be 3. B squared is 4. So B must be 2. So here's how I graph this. I know that it's elongated horizontally because the bigger number is underneath the x. So I take from the center 0, 0. By the way, my center is 0, 0. Okay. I take the distance A, which is called the length of the semi-major axis, and from the center I go that far to the right, put a point that far to the left. So 3 to the right, 3 to the left. Those are my foci. My foci are, I'm just going to kind of quicken it up there a little bit, plus or minus 3, 0. Alright, my co-vertices are B units away from the center, so B is 2. This was B squared was 4, excuse me. B is 2, so that's 2 above and 2 below. And those would be my, as the book has a tendency to write it, as I mentioned before, they don't use the term co-vertices very often. They use minor axis endpoints. I'm going to abbreviate here a little bit. Minor axis endpoints. That's my own makeup. And this would be 0 plus or minus 2. Those 2 points. And now it's just a matter of sketching it. And just do the best you can. It's not 4 little line segments. It should be a curve, and it should have some symmetry there, although this side certainly kind of messes that up, doesn't it? That's a little bit more. So you get the oval shape. Now it's not pointy yet there. It should be a curve. The only thing I don't have listed are the foci. Now the foci are going to be on the major axis, so it's on the x-axis here. My foci are C units from the origin. Remember the foci back here? C0 and opposite of C0, but I don't have C. I have A squared, I have B squared, but I don't have C. That's where this comes into play. Put it over here. A squared equals B squared plus C squared. So that gives me 9 equals 4 plus C squared. That gives me C squared is equal to 5, so C is equal to the square root of 5. Now, if you're looking for a negative square root of 5, C is defined to be a positive number here. So, and here, that's C for the center there. Oh, that is a bad choice. Actually, that's C for this length there. Take that back. So I'm going to have for my foci here, just not going good today when I keep making mistakes like that. Okay, these are my vertices. Vertices. If I can spell it, that would help as well. Those are my vertices. Sorry about that. Screwing up all over the place. Sorry about that. My foci are plus or minus the square root of 5, 0. I think that's a mistake easy enough corrected by what I just did here that I don't need to start this video all over again. And I'm hoping that you'll forgive me for all the mistakes I made naming off stuff. Alright, so let's see if I can do a better job with the next example. Graph the ellipse and identify the center, vertices, minor axis endpoints or co-vertices, and the foci. Now this does not look like standard form. And by the way, these are referred to as standard form for the equations of ellipse. It doesn't look like either one. See how both of them have equal 1 and this has equal 900. So the first thing I'm going to do here is I'm going to take this equation, I'll bring it over here because I got a little bit more space, 25x squared plus 9y squared equals 900. I'm going to divide through by 900. That'll make it a 1 there, and hopefully make it look like one of those guys. Now, 25 goes into 25, 25 goes into 900, 36 times. I have x squared over 36 plus 9 goes into 9 once, goes into 100 times, y squared over 100 equals 1. that looks a lot like this guy right here. This one's going to be elongated vertically. A, or A squared I should say, is 100, so A is 10. B squared is 36, so B is 6. So I'm going to, notice my units here, they're each worth 2. So on my scale here, so I'm going to go 10 from the center, 10 units up, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 10 units below. 6 units to the right, 2, 4, 6 from the center and to the left. And now I'm ready to score. Hey, you can get a pretty decent sketch if you get those 4 points. If you graph your vertices and your co-vertices. You don't need to really graph the foci unless the directions tell you to, because they don't really help with the curve since they're not actually on the curve of the ellipse. They're kind of in the interior of the ellipse. So let's see if I can make this look reasonable. That's not so bad. Alright, now I need to list all the information here. The center, 0, 0. The vertices, 10 up, 10 down, so plus or, oh, almost messed up again. 0 plus or minus 10. That's on the y-axis. My endpoints of my minor axis endpoints, is that ridiculous? Or the co-vertices would be, let's see, plus or minus 6 comma 0. Now the foci. The foci, they're going to be on the y-axis, so I know it's 0 plus or minus something because of the symmetry. They're going to be the same units above, C units above the center as C units below the center. I just need to find out what C is. So go back to this guy right here. You can see that B squared, or what we have, A squared is equal to B squared plus C squared. This is A squared, this is 100. B squared is 36 here. 36 plus C squared. Still making mistakes. Subtract 36 from both sides and take the square root, and I'm going to get C is equal to 8, so it's going to be plus or minus 8 as far as the foci. 0 comma plus or minus 8. Now they're not all with center 0, 0. So we're going to need to generalize this and have any point as the possible center, and that's coming up in the next videos.